Back to another Leetcode video. Today we're going to be doing the daily challenge 1143 longest common subsequence. This is a medium problem and this is a dynamic programming problem. So let's read the description. Given two strings, text 1 and text 2 return the length of their longest common subsequence. If there are no common subsequence, return 0. A subsequence of a string is a string that is generated from the original string with some characters can be deleted without changing the relative order of the remaining characters. For example, ace is a subsequent of A, B, C, D, E. So we can see that they deleted B and D and they got ace. So here we have the ace, and then here, yeah. And then the final output would be 3. You just output the number. And then here, nothing, so it's 0, right? So let's go ahead and look at the constraints. So the length is 1 to 1000 and they're only lowercase. Okay. We got 2 hints. Let's look at these. Try dynamic programming. The PIJ represents the long subsequence of text 0. Okay, so basically what they're telling us to do is make a 2D array or list. And then like the last video with the paths, it's gonna be something like that where you would like solve the least I mean turn this big complex problem into smaller problems, and then based off that you would get the answer. Let's see text hint 2. dpij equals dp plus 1. Okay, so basically this kind of gave us everything. So this is telling us that we would fill this dp array with the number with basically plus 1 if the two texts are the same, and then if they're not, then we would uh make it the max of uh I minus 1 or j minus 1, like depending whichever one's higher. So I mean, of course we're gonna have to do the 2D array, so I'll just call it dp. And then so this doesn't help in big O notation, but almost always array comprehension is much faster in Python than just doing it regularly. So we're gonna, list comprehension is much faster, so we're gonna be doing that. So initially, we're gonna just set everything to 0. So we'll do, and again, we're doing 2D. So here, this would be the first dimension for j in range, uh, length of text 2 plus 1. So this plus 1 is so we don't go out of bounds when we're indexing. Yeah. And then so we're gonna add this for I in range, lang text 1 plus 1. Again, this same thing. So now we have to do the double for loop. So we have to go through everything basically. And then so what we're gonna do is we're gonna do a bottom up approach. So we're gonna start at the bottom and then go up. So minus 1 minus minus 1 minus 1. So yeah, we're gonna start from the bottom, and then same thing for the other one. Okay, so now let's look at these conditions they give us. So if these two are equal, well, they kind of gave us this, so let's just copy and paste it here. So what should we do if they are equal? Well, we'll kind of get back to that. So we would have to do something if they're equal, and then also do something if they're not equal, right? So let's go ahead and just do the equal first. So they say if the texts are equal, Uh, yeah, so we would do this, right? So let's just go ahead and do it. We do dp I add j, and then so if they're equal, then we would add 1 uh equals 1 1 plus the previous one. So because at the end, what we want to do is we just want to return the top left of the dp array. So we add 0 0, because we're going from the bottom to the top. This is where our answer would be. If you do top down, then it would be like the opposite. I plus 1, j plus 1. And then, so what would we do if it's not equal? So if it's not equal, we would do the max of that. I mean, we're gonna do an iteration of that. So max, we would set it to I, j equals max of the uh bottom, or no, not the bottom, but basically either I plus 1 or j plus 1, because we're doing it top down. I mean bottom bottom up, yeah, bottom up. And and I think that's about it. So the time complexity for this would be n times m, so text 1 times text 2. And I mean, same for the space complexity, like, since we have to make a uh big list here. So let's go ahead and run it. Hopefully it works. Okay, so let's submit. Okay, and it's decently fast. Let's see what the top one did. Hmm. Okay, maybe this early return. Let's see how much it would help us. Probably not, since the more you submit, the slower your uh it is usually. So let's just submit. I think it might help us pass a few. Oh, S. And here it doesn't matter what you return. Oh, why did I run it? I meant to submit. Okay, kind of did make it a lot slower. Okay, yeah. See, the early return literally doubled the time, the speed. Yeah, well, I mean, yeah, sometimes, I mean, most of the time this would be a good thing. Well, all right, thank you guys for watching the video. Make sure to like and subscribe, comment, connect with me on LinkedIn, and I'll post another video tomorrow.